All right, this video is about using sum and difference formulas to find angles, an angle's sine or cosine. All right, so sum and difference formulas. We use sum and difference formulas to help us to find the sine or a cosine of angles that do not appear on the unit circle. Okay, the formulas are as follows, and you can see all the formulas right there. They are on your formula chart. They're in the ones I have in the classroom as well, so you don't have to memorize these, but just notice what they are. Like the sine of two angles added is equal to the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. If I needed to subtract two angles to find the whatever angle they wanted, it would be a little different in that I would take the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. Now, if I'm looking for cosine, there's different formulas. If I added two angles to get the desired angle, I would take cosine of A times cosine of B minus sine of A times the sine of B. If I needed to take the difference, look at what happens. I take the cosine of A times cosine of B plus, so it's almost opposite signs here, sine of A times sine of B. Now, like I said, you don't have to memorize these, but just be aware of the differences between them. So how do I use them? The problem will read, find the exact value in simplest radical form. It's a cosine problem, so I put the two cosine equations here. All right, it's a minus sign, so I'm going to use it's a minus sign, so I'm going to be using the one that's subtraction, so we can ignore this one for a moment. All right, but let's just think about this. 11 pi over 6 minus 5 pi over 4. If I got a common denominator on this, to find out what angle I'm really talking about, the common denominator would be 12. So I would do 12 on the bottom, multiply both by 2. I'd have 22 pi minus, this one I'd have to multiply by 3, so that'd be 15 pi. So it's asking me for the cosine of 7 pi over 12. That's not one of our angles on the unit circle. That's why we have to use the sum and difference formula. All right? So that said, come back to this, and let's look at our two angles that are on the unit circle. So notice I use two angles that do appear on the unit circle. The first one is your angle A, the second one is your angle B. All right? So then I look on my unit circle and I find out, okay, what are the coordinates at angle A? So at angle A, my coordinates are the square root of 3 over 2 and negative 1/2. Angle B has the coordinates of negative square root of 2 over 2 and negative square root of 2 over 2. Okay, using those two coordinate pairs, I can use these formulas because you remember y is the sine, x is the cosine of theta, right? It all goes back to this principle. Okay, so now I'm just going to use this formula, plug in the values, all right? So, equals cosine of angle A. So it's asking me the cosine of 11 pi over 6 times the cosine of 5 pi over 4 plus the sine of 11 pi over 6 times the sine of 5 pi over 4. Alrighty? Now, we plug in values. Okay, what is the cosine of 11 pi over 6? That's angle A. Well, the cosine is square root of 3 over 2 times the cosine of 5 pi over 4. That's negative square root of 2 over 2. Plus the sine of 11 pi over 6, that's negative 1/2, times the sine of 5 pi over 4, negative square root of 2 over 2. All right, so order of operations says I need to do the multiplying first. So here I have square root of 3 times square root of 2, negative square root of 2. So the negative carries because it's a positive times a negative. When you multiply radicals, you just multiply the inside to the inside. So I have the square root of 6 over 4. Remember, multiplying fractions straight across. Plus, negative times a negative means it's going to be positive, right? So it's 1 times square root of 2 over 4. 2 times 2 is 4. So now I just combine it, and I have negative square root of 6 plus the square root of 2. I cannot combine these because they are not like terms, over 4. And this would be my answer. So most of your answers today are going to look similar to this with radicals as a fraction. Okay? Let's try another one. Let's try sine. Uh-oh, what if it is as a degree? Well, we have degrees on the unit circle. We can handle that. It's sine, and it's a difference problem, right? So I'm going to use this equation right here. This is angle A, this is angle B. So I'm going to do the sine of 135 times the cosine of 30. That's not negative 30, it's just 30, right? Using positive angles only. Minus the cosine of 135 times the sine of 30. All right, so let's look at our unit circle and get our points, okay? Angle A is 135, and the coordinate pair there is negative square root of 2 over 2, square root of 2 over 2. And 30, what's the coordinate pair there? Well, it's square root of 3 over 2, 1/2. Okay, remember, y is the sine, x is the cosine. Please know that. Please, please, please. All right, so now I'm going to plug in values. The sine of 135 is the y coordinate, so I'm going to do square root of 2 over 2 times the cosine over here, square root of 3 over 2, minus the cosine of this, which was negative square root of 2 over 2, times the sine of 30, which is 1/2. All right, do these parts first. Okay, square root of 2 times square root of 3 is square root of 6 over 2 times 2 is 4, minus negative square root of 2 plus 1 is negative square root of 2, so this is going to become a plus. And 2 times 2 is 4, so my answer is square root of 6 plus the square root of 2 over 4. All right, that is my answer. Now, I'm going to take this answer. I want you to remember this answer because it's going to be important as I show you the next problem. But this is the basics on how you do it. Pick the right formula, plug in the right values. Now, some of you may be saying, hey, can't I just take the sine of 135 and subtract the sine of 30? Is that the same as this? It is not. They are not the same. So, what we just found is our answer was square root of 6 plus the square root of 2 over 4. Okay, that's the solution we just found. So I'm going to work it out just like this so you can see that they're not the same. Okay, you have to follow the formulas. So if I do that, the sine of 135 minus the sine of 30. Okay, remember our 2 points. Angle A was negative square root of 2 over 2, square root of 2 over 2. And angle B was square root of 3 over 2, 1/2. All right, so the sine of 135 right here is the square root of 2 over 2 minus the sine over here, 1/2. Well, that's the square root of 2 minus 1 over 2, right? Is this the same as this? No, they are not the same. So which one's correct? The one that's correct is the one that came from the formula. So this is your correct answer. So don't think you can distribute. It's not the same thing, okay? Otherwise, it's just following formulas and plugging in values. So be careful of signs. Be careful that you're picking the right points off the unit circle. But other than that, that's how you do this problem.